Hello, everyone, and welcome back. My name is Ian, and I am here to deliver you our end of the month for June Project 87 Roundup. So, it's been a while since I released the last video. If I'm looking at this correctly, the last video was for ankle joint testing for our version 5 endoskeleton. I'd just like to say that I've been working on that quite a lot recently, and it's been coming along quite well. I have a few more parts on the printers as I'm making this video right now. So I imagine by the end of this week, say by July 1st or July 2nd, maybe July 3rd, I might be able to have that assembled and ready for testing in the coming weeks. So my plan is I'm going to be testing out the actuators in the hips to see how strong they are, starting with the one that rotates the thigh forward and backwards. Because if that motor is strong enough to do it, say on 4 batteries or so, then I have no doubt the rest of them should be able to do the job just fine. And again, if I can determine quickly if those motors will be capable of driving the entire robot, then I can carry on with no interruptions to that. A member of our Discord server asked a couple questions regarding what kind of computing power our robots will actually require. Say if we were to compare our modern computers to the computers used in animatronics back in the 70s and 80s, it's come quite a long way in such a short amount of time. If we look at, say, the animatronics in the Five Nights at Freddy's series, say from the 70s onwards, from like Fredbear's Family Diner going forward, they were really just static animatronics on stage that could double as a human wearable costume at the same time to walk around. Whereas later on, as the series developed, we've seen that the animatronics could actually be capable of navigating and walking on their own, especially in the latest installment in the franchise, where they're basically full-fledged self-thinking machines at that point. So we can make the same comparison to real life, where if we look at animatronics again in the 70s and 80s, they had very simple pre-programmed routines and movements they were performing on stage. They weren't actually going anywhere. And if we look at modern robots, for example, they're capable of navigating, capable of picking up objects, recognizing faces and speech, and capable of operating on their own. If we look at the robots that Boston Dynamics makes, like Spot and Atlas, etc. So if we were to be able to provide our machines and our animatronics with the same kind of capabilities, they will require their own high-powered computers on board. Now, it's not practical to have them carry around a desktop computer with them everywhere they go. And even at that rate, if we wanted to have them connect to cloud servers for computing, we have to run into privacy issues then. And if there's a loss in internet connection, then they won't be able to perform speech recognition or computer vision or anything like that. Which is why it's important that we provide them with the computing power on board in a practical and portable package. So going forward, we'll be using a combination of low-powered microcontrollers to deal with interfacing with the motor drivers and sensors, accelerometers, gyroscopes, things like that, and any of the real-time AI related things like machine vision, navigation, speech synthesis, speech recognition, and just general AI in general, that will be done on a laptop computer on board. For a couple reasons. One, it provides the ability to use a dedicated graphics card in such a compact package, and we can run a lot of AI and neural network applications on the GPU. Second, modern processors on board these laptops have come a long way in such a short amount of time. When I bought one of these laptops about 4 years ago, it was lacking in power for the same price that I got one 8 months ago at, and it's like night and day, to be honest. If you actually look at the video I recently recently posted, it was our speech recognition test. I'll provide a link in the description. That one is actually running on the same laptop that we'll actually use on our first robot. And it's capable of running synthesis and speech recognition in real time, or close to real time. Again, it's entirely limited by the graphics card that's on board, but I imagine as they get better in the future, it'll it'll just get more power efficient, hopefully, and more powerful as time goes on here. What's coming up in the next while here? So I already mentioned I'll be testing out the motors and starting to synchronize joints together on the lower body. And in short order here, we'll be able to get it balancing on its own. Uh, I haven't shown anything yet of the version 5 endoskeleton aside from those two ankle joint prototype videos that came out in April and May, because I've been working quite a lot on this and it's just about done. It's fully assembled at this point, barring a few parts that are just on the printers right now, and you're going to see it very shortly. It'll be assembled by this coming weekend, so that will be July 2nd, July 3rd, and July 4th at the absolute latest. So I don't want to keep this video too long. I want to make it as short as possible. So, yeah. Looking forward to providing more updates as time goes on here, and we'll see you shortly. Take care.